Good morning. Happy Friday. The only thing I'm going to do on this video is go over the Half-Life Reactions homework that will be due today, actually, by noon. Reminder that you have a quiz that's due today by 3:15, and you should be kind of working on the M&M lab that will be due next Wednesday at 3:15. Okay? You can see the joke of the day. It's not the best, but it's all right. Okay, let me find the homework. Might be this one. Come on. That's it. Okay. So I'll go through these as quickly as we can. It should only take about 10 minutes. In each of these cases, you're going to need your reference table. What table in your reference will you need to answer these problems? Well, actually, I'm going to pull that up, please. I had to restart my computer. So we're looking at table N. Table N is the one really that you're going to need. Ooh. All right, so how do I do these? Sample of potassium-42 is allowed to decay for 74.4 hours. How many half-life periods went by during this time? Well, if that's all I know, I must have to go somewhere to get more information. So we've got potassium-42, that's K42. So I'm going to scan this to see where that is. And here it is, K42. It has a half-life of 12.36 hours. Okay, it also goes through beta, but that's not part of the problem. But it would be good to practice that at some point. But 12.36 hours. So I'm going to take 74.4 hours and divide it by 12.3 hours, and that comes out to be 6? It's going to come out to be close, pretty darn close to 6. So 74.4, 12.3. Okay, 6.05. So when we do these, we're going to do a little bit of rounding here. Okay? How many half-life periods went by during this time? So 12.3 hours, 74.4 hours, that's 6 half-lives. What is the fraction remaining after 74.4 hours? So if I have a half-life each time, there's 1 half-life, 2, 3, 4, 5, and 6. So, what fraction? Well, since it gets halved each time, then the last fraction that I'm going to have, what remains, I have to multiply all these. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So what's going to remain is 1/64th of what you started with. So 6 half-lives, 1/64th. Okay, let's try the next one. Number 2. Sample of radon-222 is allowed to decay for 11.46 days. How many half-life periods went by during this time? What is the fraction? So these questions are essentially going to be the same thing. What am I looking up? Radon-222. Radon-222. There it is. What is its half-life? 3.823 days. 3.8323 days. So it's 11.46 over, what did we say? 3.823. 3.823. So what does that come out to be? 3 times, that's going to be 3, pretty close. 11.46, 3.823. Okay, so that's essentially 3 half-lives. So how many half-lives went by? 3. What is the fraction remaining after that many days? Same thing as that. 1 half-life, 2 half-lives, 3 half-lives. 2 times 2 is 4, times 2 is 8. 3 and 8. Okay? Number 3. 1 gram sample of francium-220 is allowed to decay for 110 seconds. How many half-life periods went by during this time? Same thing. Francium-220. Francium-220. Where are you? Francium-220. There it is. 27.4 seconds. 110 seconds. 110 seconds under 27.4 seconds. It's going to be about 4, I'm going to guess. 110 divided by 27.4 is 4. Good guess. So 4 half-lives. What is the fraction? Same thing. 4 half-lives. Half times half times half times half. 2 times 2 is 4, times 2 is 8, times 2 is 16. So a 16th will remain. What mass of francium remains after 110 seconds? Okay, so now we're adding to it. Now we've got another factor here. So let's pull this up a little bit more. 1 gram sample. So this is how I'm doing this. 1.0 grams. How many half-lives does it go through? 4. So I'm going to have the same size, and over what I showed you in the notes was I'm going to stripe that part, just to visualize it, that is radioactive. Now you know that in a sample it's not going to be 1/2 or the other, it's just going to be random. So over 27.4 seconds, half of it will be gone. So what's left? 0.5 grams. Here's another one. Another half-life goes by. And 27.4, you could put that each time, seconds. Half of that. So now I'm at this stage. Half of 0.4 is 0.5 is 0.25 grams. So there's 2 half-lives. I need 2 more. Drawing the same size. Half of this is about that. Half of that is this. And my last half-life is half of that. So that's just kind of a little sliver here. And what's half of 0.125? 0.625. I think that's right. Unless it's 0.625. Hold on. 0.625, sorry. 0.0625. Okay? And that's grams. So, what mass will remain after 110 seconds? 0.25 grams. Okay? Now, when you are doing these, please be careful. You have to look at the number of arrows. Those are the half-lives. Seconds and seconds. Don't count the samples each time. Some people do that, they get confused. Number 4. 32 gram sample of iodine-131 is allowed to go for 40.35 days. How many? Same question. This time I'm looking for iodine-131. There it is. 8.021 days. So 40.35 days over 8.021, is that what it was? 0 to 1, 0 to 1 days. That's going to be 5 pretty much. Okay? How many left? So 5. What is the fraction remaining after that many days? Well, that's after 1 half-life, 2, 3, 1, 2, 3, 4, 5. So there are my 5 half-lives. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So what's going to be left? 1/32. Okay? That's all they ask. They don't ask how much will be left. All right, number 5. After 36 seconds, that many grams of nitrogen-16 remains. What was the mass of the original isotope? Okay, so now it's the next level of difficulty. It remains. So in this case, I have to start over here. And 6.25 grams remains after 36 seconds. So, this is another piece. I have to look up nitrogen-16. Nitrogen-16 is here. It's 7.13 seconds. So, 36 seconds, 7.136 or something like that. What's that going to be? Basically 5. 5 times 7 is 35, and then this. So this is going to be 5 half-lives. Yes? I'm pretty confident, but I don't want to go through the rest. 7.136. Okay, it's 5. A little bit of a remainder. Okay, so that means there are 5 half-lives. What was the mass of the original isotope? So I've got to get back over to here, yes? I've got 5 half-lives. So here's 1, here's 2, here's 3, 4, and 5. 1, 2, 3, 4, 5. Count the arrows. Don't count the samples. So if I've got 6.25 remaining, what happened from here to here? It got halved. So if I'm going backwards, I double it. So this 6.25 times 2 is 12.5. 12.5 times 2 is 25. 25 times 2 is 50. 50 times 2 is 100. 100 times 2 is 200. Okay? So that is a little bit more complicated since they're telling us how much we are left with. Okay? And this last one, I don't like the wording of it very well. I don't like it very well. But it says what was the original isotope. It really should say what was the mass of the original. Okay, so let's look up cobalt-16. Cobalt-16, wait, cobalt-60. Sorry, cobalt-60, my fault. Cobalt-60 is 5.271 years. 5.271 years. 15.78 years. 5.271 years. Well, you can tell it's going to be pretty close to 3 half-lives. Okay, so after that many years, 10 grams remains. So this is similar to this question. And I'm starting over here with 10 grams of the cobalt-60. I've got 3 half-lives, so I need 3 arrows. So there are my 3 half-lives. Each one of them is 5.271 years. 5.271, 5.271 years, years, and years. So, 10 grams remain. How much will be here? Well, from here to here it went half. So from here to here, I have to double it. 20, 40, 80. So if I started with 80, after 5.271 years, 40 will remain. Another half-life, 20, another half-life, 10. Answer, 80 grams. Okay? We'll do more of those on Monday. Good luck.